All right, so ladies and gentlemen, we're going to start doing what we call inverse trig functions. Again, inverse sine, inverse cosine, inverse tangent today. Okay. Now, we have done inverse trig functions already. So if you guys remember in chapter 8, right? In chapter 8, we gave you a reference triangle like this, right? Little reference triangle, and we said, hey, I need to come up with this angle right here. And we knew this guy was 1 and this was 2. And then we set up SOHCAHTOA, right? SOHCAHTOA from this angle. What's this guy? OA or H? Oh, what's this one? H. And then we wrote out SOHCAHTOA. And then we had to figure out which one has an O and H. We used Goldilocks. This one has an O, but no H. This one has an H, but no O. Ah, this is just right. Okay? And then we set up our angle, sine of our angle, opposite over hypotenuse. And then we did the inverse of 1/2 to get that angle. Right? And we used our calculator. We typed that in. We did second sine. And we typed in 1 divided by 2. And we pressed enter. And we got 30 degrees. Okay, so that's what we did in chapter 8.1. First thing we did. Any questions on what I'm doing? So that's basically what we're doing today. We're essentially going backwards. Okay, so in chapter 6, we said, hey, what's the sine of 30? Right? And then you guys drew your little reference angle, right? Here's 30 degrees. Drop it like it's hot, make it a 90 with the x. This guy's 30. What's across from 30? 1. This is 2, and I want O over H, which was 1/2. Well, now we're going to say, hey, what's the inverse sine of 1/2? And you're going to give me the angle. You're going to say that's 30 degrees. We're going to convert that to pi over 6. So it's going backwards from what we just did in chapter 6. In chapter 6, you guys did awesome on that first part of that test. Trying to find out what the sine of 30 is. You guys were able to do that very well. Well, now you're just going backwards. Okay? So if you did well on that chapter 6 test, oh man, you're going to do great on this one. It's just going backwards. So here we go. We're going to work with inverse sine, and inverse sine says that it works from negative pi over 2 to pi over 2. So inverse sine says it goes from negative 90 degrees to 90 degrees for you degree people. So as we take a look, visually, here's 90 and here's negative 90. We're going to be drawing our triangles in 2 quadrants, in quadrants 1 and 4. So if you have a positive ratio like 1/2, root 2 over 2, root 3 over 2. If it's a positive ratio, you're going to draw your triangle in quadrant number 1. And if you guys have a negative ratio like negative 1/2, negative root 2 over 2, or negative root 3 over 2, you're going to draw it in quadrant number 4. Just remember when you're doing quadrant 4, that's 0 to negative 90. So any angle in quadrant 4 is going to be a negative angle, negative 30, negative 60, negative 45. Okay? When you look at inverse cosine, you'll see that it works from 0 to pi. Again, a reminder, pi is 180. So it goes from 0 to 180. So visually, I always like to draw it out what it's going to look like. You're going to be working from 0 to 180. That's quadrants 1 and 2 we're going to be drawing in. So if it's a positive ratio of sides, 1/2, root 3 over 2, root 2 over 2, you're going to draw that in quadrant 1, just like inverse sine. But if it's negative, remember cosine is negative on the left side, so that we're going to be in quadrant number 2. So if it's a negative ratio, negative 1/2, negative root 2 over 2, or what have you. Just a reminder, in quadrant number 2, it's obtuse. We're talking about angles that are between 90 and 180, so it's going to be a big angle. Okay? All right. Any questions on what we're talking about here? So let's put this into action. As I take a look at example number 1, I got inverse cosine of 1. And I want to find out what angle gives me where cosine is 1. Anytime I'm talking about 0 plus or minus 1, we are not thinking triangles, guys. We are thinking circles for inverse sine and inverse cosine. So we're going to use that unit circle that we have over there. And we're going to look to see where is cosine 1. Where is that at? So look at your unit circle over there by Tommy. Where's cosine? SOHCAHTOA. Katie, where are you looking? Right here. 0, 1, 0. Remember, this is in terms of SOHCAH and TOA. So cosine is 1 right there. And what is that angle? What's theta? What is that guy? No? This is just 0, right? That's 0 degrees, which is the same thing as 0 radians. If you just said the answer is 0, that's fine. I would totally accept that. Okay. So that's 0 degrees or 0 radians. Now, some people might say, well, isn't that 2 pi? Yes, but technically we're only working from 0 to pi. So your answers are only from 0 to pi. Don't include 2 pi. And that's it, guys. We're trying to find the angle now. Okay? So let's put this in action again. I've got example 2. I've got inverse cosine of root 2 over 2. So again, inverse cosine works in 1 or 2. If it's a positive root 2 over 2, I'm going to draw this triangle in quadrant number 1. So here's quadrant number 1. Initial side, terminal side, drop it down, make a 90. Cosine is Ca, A, and H. So I know where H is. I know H is the diagonal. That's this guy too. But now I got to find where to put the A. A, where do I put that? Where do I put that A value? Up and down or side to side? A. Yeah, A is side to side, right? A is right here. Remember, opposite is always up and down. That's going to be root 2 then. So if I'm looking at my reference triangles, I got root 2, and 2. So then what I need to know is what's this theta? What's this guy right here from my initial side to that terminal side? How many degrees is that? That's 45 degrees right there. It's 45. Okay. Now, quiz or test, I'll again have reminders that, hey, you need to do radians. So just a reminder, if I have 45 degrees, just divide by 180. Math bracket, you would get 1/4, put a pi on top. You get pi over 4. Speed sheets, you guys probably have that memorized now, right, Katie? Right? No? All right. Quiz or test, you're freaking out. I don't know what the answer is. Well, this was going to give you some help. Okay, so if I have my calculator, number 1, I'm going to be in my mode. I'm going to be in, I like to be in degrees myself. Okay, so I understand what's going on if I'm not really good with radians. So check your mode, make sure you're in degrees. And then I'm just going to do inverse cosine. So second cosine is the inverse cosine. And then root 2, so square root of 2. Use your directional pad and get out of that. And then divide by 2, and I'll get my answer of 45. So that's my angle. And now I've got my answer in terms of radians. So I can divide by 180. Math frac, put a pi on top. I got pi over 4. Okay. Just going backwards. We're giving you the ratio of sides. Now come up with the angle. Okay. All right. Any questions, y'all? Questions? All right. Push the clutch in. Switching gears here. We got inverse sine now. Inverse sine of negative root 3 over 2. If I look at negative root 3 over 2 for inverse sine, I'm in quadrant 1 or 4. So I'm in quadrant 4 because it's a negative now. Okay, reminder, if I draw in quadrant 4, that angle is going to be negative. So again, I've got sine, O and H. I'm in quadrant 4. Initial side, terminal side. Now I make my reference triangle. The 90 is always on the outside on the x-axis. And now I got my h. That guy's 2. Hypotenuse is done. Where's the opposite go? That's the most important side. Side to side or up and down? Up and down, yes. That's the negative root 3. If you want to put the 1 here, that's perfect. And now the angle that I care most about is this guy from the initial side to terminal side. What's across from root 3s, or in this case, negative root 3? 60, but it's going down. It's yelling timber. That is a negative 60 because it's going down. Speed sheets, that's negative pi over 3. Just a reminder, if that's got a 6, then the radian's got a 3 in it. If you're not good with that, just take negative 60, divide by 180, put a pi on top. You get negative 1/3 pi, which is negative pi over 3. So final answer, guys, negative pi over 3. Okay, if you're freaking out, quiz or test, like, I don't know what this is. I don't remember what I'm doing. Throw it in your calculator. It knows. Just make sure you're in radians or in degrees. Inverse sine, so second sine, negative. Use the little negative sign. Square root 3. Use the directional pad to get out of there. Divided by 2, press enter, negative 60. Divide by 180, math frac, there's your negative pi over 3. If you're getting a decimal back, some weird decimal, that's probably because you're in radians. Okay. All right, who's got number 4? Inverse sine of negative 1. Where is sine negative 1? What do you got? 270 down here at the bottom, right? So a reminder, if you see 0 plus or minus 1 for inverse sine, inverse cosine, think circle. So again, down here, negative IOU is what we call it. Sine, cosine, tangent, we're looking right there. Now, yes, that is 270 if we're going this way, but inverse sine works in these two quadrants, right? So what is this guy going down? Yeah, that's negative 90 degrees, which is negative pi over 2. Okay, so my math lab, if you type in 3 pi over 2, it's going to be wrong because they're going down. They're doing a negative angle. So Nick, good job, bud. Give me a thumb. Where are we at, guys? Thumb, thumb, thumbs up, thumbs sideways, thumbs okay. Again, anytime you see 0 plus or minus 1 for inverse sine, inverse cosine, think circles. So as I take a look at the last one, I got example 5. Now I've got inverse cosine of negative 1/2. So we go to cosine. Inverse cosine works in 1 or 2. So this puts me in what quadrant? Quadrant number 2. So initial side, terminal side, that's this angle right here. This is theta. That's what I'm trying to figure out. The big angle. Remember, quadrant 2 is obtuse, between 90 and 180. Well, we still make our reference triangle. We still drop it like it's hot. And we got A and we got H. So this guy's H. That's 2. Where's A? Side to side or up and down? Yeah, it's always on the x-axis, side to side. Yes, that's negative 1. Now, what's this side from our reference triangle? That's root 3, right? And now we need to come up with that angle. What's across from root 3's? 60 degrees, right? Now, what I'll get is people will say the answer is 60 or pi over 3. And then they type it in, and it's wrong. It's not 60 because we're in quadrant 2. We want the big angle, right? So if that's 60, what's this theta? How do you find it? If you want the big angle. Yeah, Dan, what are you saying? Yeah, take 180 and subtract that little reference angle. That'll give you the 120 degrees. Okay. So 120 ends up to be, speed sheets, 2 pi over 3. So final answer, 2 pi over 3. Again, beautiful thing, quiz or test. Check your work before you move on, right? I say this and nobody does it, I don't think. I don't know. Do you guys check your work on tests? Yes. Sometimes. Sometimes. Should be all the time, right? You want that Gotsch tip pencil, man. All right, 120. There you go. 2 pi over 3. Got it right. All right, all right. Do you guys have any questions on 1 through 5? We're finding the angle. The angle's got to be, again, in radians, and anything in quadrant 2 is obtuse. Anything in quadrant 4 is a negative angle between 0 and negative 90. So when you take a look at number 6 and 7, now we're switching gears into third gear. We're looking at inverse tangent. And inverse tangent, just like who? Works in 2 quadrants, just like which one up there? Which one is it like? Is it like inverse cosine or inverse sine? This is just like inverse sine. This works from negative 90 to 90. If you look at the inequalities, though, inverse sine includes negative 90, 90, and inverse tangent does not. It's not equal to, because the tangent of 90, the tangent of negative 90 is undefined. It's the IOU, right? So if we look up and down at pi over 2 and negative pi over 2, it is undefined. That's why it's non-inclusive there. Okay, but big idea, this is pretty much just like inverse sine, where it goes from 90 to negative 90. If it's positive, you're still in quadrant 1. So all 3 of them are the same if it's a positive ratio. But if it's negative, it's in quadrant 4, just like inverse sine. Okay, I will draw these 2 little circles up there on a quiz or test, and that way you have them. Or a quiz or test. All right, so let's put this into action here. I take a look at example 6, I got inverse tangent of root 3 over 3, and I go, oh yeah, I've seen root 3's before, and I look at my reference triangle and I go, wait a second. The reference triangles I know are 1, root 3, and 2, not root 3 and a 3, because again, these are reference triangles. These are my O's and A's, TOA, tangent, opposite over adjacent. And I don't know an adjacent leg that has a 3 in it. So then I got to start thinking, well, what happened? How did they get root 3 over 3? Mac? Yes. Yeah, the person that did this one didn't want to be a dirty rat, right? So they rationalized it. So you need to unrationalize. Very good. So you can take this root 3 over 3 and unrationalize it. I'll show you this one time, and then after that you can just do some math magic. Root 3 times root 3 is 3. 3 times root 3 is 3 root 3, and Megan is right on. You get a 1 over root 3 when you unrationalize. Okay? So the inverse tangent of root 3 over 3 is the inverse tangent of 1 over root 3 is essentially the answer, or is essentially the question. Is that making sense or not making sense? Any questions? So usually when I see this, I'll go right to this. And I'll say, okay, now my opposite is 1. Now my adjacent is root 3. John, you got that back there? Kev, good? Thumbs up? Okay. It's a positive ratio, so I'm drawing it in this quadrant. Quadrant number 1. Get it so you can see it here. Again, root 3 times root 3 is 3. 3 times root 3 is 3 root 3. The 3's cancel. Gives me this. So working from this angle, this is the angle I'm looking for. This is opposite. This is adjacent. This is hypotenuse. That's 1. That's root 3, and that's 2. Well, the angle that I want is this guy. And what's across from 1? And our reference triangles. That's 30 degrees. Across from 1 is 30, and that is pi over 6. Pi over 6. We're getting a reminder, if this is 30, then in radians it's going to have a 6 in it. 6 and 3, 3 and 6. So final answer, pi over 6 is what I'm looking for. Okay, good stuff. All right. Last but not least, for number 7, as I take a look at number 7, I've got inverse tangent of -1. Now, I remember up here, Mr. Gotsch said if you have 0 plus or minus 1, think circle. Well, that only works for inverse sine and inverse cosine. So inverse sine, inverse cosine, if I see 0 plus or minus 1, I'm thinking circle. That does not work for tangent. If I see plus or minus 1, for tangent, I got to think something different. I got to think, hey, this was an opposite and adjacent leg, and they completely reduced and gave me 1 or -1. Well, where does that happen where opposite and adjacent completely reduce and give you 1 or -1? What do you know about O and A? What happens when you have two numbers and they divide out and give you 1? What do you know about those two numbers? They got to be the same, right? And in this case, they're both the same or equal, except one's a plus and one's a minus. Well, where does that happen? What type of triangle? Where the two are the same? Of your two legs. 45, 45, 90, and an isosceles triangle. Very good. So when you guys see 1 or -1 for inverse tangent, I need you guys to start thinking 45, 45, 90, where opposite and adjacent have canceled out. So this is essentially the inverse tangent of -√2 over √2. It's just been reduced. So again, this is opposite, that's adjacent. It's negative, so I'm in quadrant number 4. Initial side, terminal side, that's the angle I'm looking for. That's opposite, that's adjacent. That's a -√2, that's a √2, and that's 2. I want this theta, I want this angle right here. What is that? -45, but it's going down, right? So it's got to be -45 degrees, which is, yep, -pi over 4. Very good. So final answer, I should get -45 degrees, which is -pi over 4. Quiz or test, I'm freaking out. Well, don't freak out. Just calm down. Well, what does I get when I put in my calculator? Inverse tangent, -1. I press enter, boom, -45. Oh, okay, I can do this. I can do this. Okay. All right. Questions, y'all. Seniors, you still got a good month, right, seniors? And there is no such thing as junioritis, right? It's only senioritis, right? Some of you guys need to do some homework. Chapter 7. Come on. All right. Last but not least, real quick example, 8 and 9 on the back. When we do tomorrow's notes, you'll start seeing that we're going to start putting some of these guys together. Like here, I got cosine of the inverse sine of √2 over 2. Like, what are we doing here? And then here's the inverse cosine of the cosine of -pi over 3. And you're like, what? Okay, so what we're doing tomorrow is going to help us for what this is talking about. This is trying to get you ready to start seeing some of this stuff. So basically what this states is the inverse sine of the sine of u is u only if u is between -pi over 2 and pi over 2, between -90 and 90. And the sine of the inverse sine of v is v only if v is in between -1 and 1. There's some constraints there. All right, so you'll see that there are actually 6 of these. 1, 2, 3, 4, 5, and 6. And now you don't have to memorize these on a quiz or test. I wouldn't be freaking out about this. So there's 6 of them here. And it says find the exact value of the expression. Do not use a calculator. For what we need it for, we're just going to say yes or no. Is the sine of the inverse sine of negative 0.05, 0.07, is that equal to negative 0.07? Is that a yes or no? So what we have to do is identify which one does it look like up here. And because it's all sines, I know it's either 1 or 2. Which one is it? Does it look like? Number 2, regular sine, inverse sine. Regular sine, inverse sine is V is equal to V, only if V is between negative 1 and 1. So my question to you is this number here, negative 0.07, does that fall in between negative 1 and 1 on a number line? So here's negative 1, 1. Isn't negative 0.07 somewhere in between? So the answer is yes. If that's yes, then that's my answer. If it's no, then I'll show you how to come up with the answer tomorrow. Okay. So when I look at example 9, I got the inverse tangent of the tangent of 4 pi over 3 is 4 pi over 3 only if it matches up with the ones with tangent. Well, which one should it match up with? Example 9 is like which one? Number 5. So inverse tangent of the tangent of u is u if u is in between negative 90 and 90, negative pi over 2 and pi over 2. So my question to you is this angle 4 pi over 3 in between those two? Now, some of you guys like looking at this in terms of degrees. Again, pi over 2s are 90 and negative 90. Okay, what is 4 pi over 3? Speed sheets, does anybody know what that one is? That's 240. Does 240 fall between 90 and negative 90? No, that's a no. So that means they are not equal to that. Okay, and eventually tomorrow I'll show you how to find that answer, okay, without using a calculator. So the answer is no. If you want to know what the answer is without showing the work, it would be inverse tangent of the tangent and of 240 because we're in degrees. And I would get 60 or pi over 3 is my answer. How do you get pi over 3? That's what I show you tomorrow. Okay? So don't freak out about 8 or 9, ladies and gentlemen. That is it. You should, you guys are packing up, you guys should be able to solve and find exact values of inverse sine, inverse cosine, and tangent with triangles and circles.